Okay, our next speaker this afternoon is Michelle Straat, account manager with INGU in Canada. Michelle has been working in the oil and gas industry for over 14 years in sales and business development with companies such as Schlumberger, Aclaro Softworks, and Sitel Canada before joining INGU Solutions. Michelle, welcome to the Virtual Pipeline Summit, and over to you to talk us through Piper's Inline Inspection as a Service, the operating system for pipeline integrity.
Good morning, Danny. Thanks so much, and welcome from Canada. It's a pleasure to be here today and welcome everyone. I want to thank you for joining me to learn about INGU and our Inline Inspection as a Service. So my name, as you mentioned, is Michelle Straat, and I am an account manager at INGU Solutions located in Calgary, Canada. Yeah, it looks like we have a clicking problem here. Okay, we started INGU about 5 years ago to address the problem that over 40% of the world's pipelines cannot be inspected with existing inline inspection methods. These are typically smaller diameter pipelines, gathering pipelines, or pipelines with sharp bends. So what we've done to solve this problem is we developed our own miniature inspection tool called Pipers. However, our core business is actually data analytics, and I'll get into that a bit more shortly. Our head office is located in Calgary, Alberta, Canada, and we also have an office in Houston, Texas. And as you can see from this map, most of our deployments have been in North America. However, we have expanded into places such as Brazil, Australia, Ireland, Nigeria, Singapore, and the UK, and these are just to mention a few. So what is it we do? INGU is actually the first in the industry to offer a self-service inspection model that eliminates significant engineering and downtime costs. So you can regularly assess your pipeline's well condition, as well as keep on top of deposits and leaks while keeping your operations going. So we developed miniature multi-sensor pipers that freely flow within operating pipelines, regardless of location, condition, material configuration, and they actually fit in the palm of your hand. So I'm probably one of the only presenters today that can actually show you the tool as I'm doing the presentation. So this is our exact Piper tool that will go in your pipeline. We offer two different types of deployments, free floating in a liquid, in liquid lines, and also attached to cleaning pigs in gas lines. So with our free floating deployment, we prepare our pipers so they are neutrally buoyant, and this allows them to flow naturally within the liquid of the pipeline. And this ensures that pipers go wherever the liquid goes, even if they're sharp bends or risers. The operator simply opens a valve, drops the piper in the line, closes a valve, turns on the flow, and it's as simple as that. Now, however, if you run cleaning pigs in your lines on a regular basis, attaching pipers to a cleaning pig is a really convenient way to inspect your lines while you're cleaning them. So having the option of the two different deployments works well for a number of companies, as some have both gas and liquid lines or multi-phase lines. So we do run two pipers for every inspection to ensure that they have the most accurate data. This also gives us a second data set so we can do a comparison. So if we see something at the same time, we know it's an operational event. However, if we see something at the same distance, then it's most likely an anomaly in the line that you might want to investigate further. So our self-service inspection process allows you to have full control by deploying your pipers by your own field operator. So there's no downtime and no need for large heavy equipment or third-party consultants. So this actually reduces the cost of inline inspection by a factor of 10, making it possible to inspect multiple assets much more frequently. In a single run, we provide highly efficient surveys, which include a leak detection, and this identifies and localizes leaks, a pressure survey, which measures the pressure profile over the length of the pipeline, deposit survey, where we locate deposits, diameter changes, and even possible collapsed liners, and of course, magnetic survey, which gives you an overall wall condition of your pipeline, and we can also detect fittings, welds, areas with severe corrosion or metal loss greater than 25%. Each piper is also equipped with 5 sensors. A magnetometer, and this screens volumetric wall loss, in particular when used on a regular basis, an accelerometer measuring the linear acceleration, a gyroscope which helps indicate orientation, an acoustic sensor for our leak detection, and a pressure sensor measuring the pressure profile, indicating changes in diameter and pipeline conditions. Our datasets library is very impressive and includes a complete range of inspection histories, such as materials, conditions, and geographies, that offer unprecedented contextual analysis and continuous advancement of our data analytics capabilities. We've deployed our pipers in various types of pipelines, and in pipelines as small as 2 inches in diameter. So we can inspect not only steel lines, but also flex steel, HDPE, fiber spar, and ductile iron. So not only can we inspect steel lines, but we can also, we're also able to locate flanges and joints even in non-steel lines. We can also be deployed in various types of fluids, such as crude oil, emulsion gas, produced water, fresh water, and wastewater. And a number of our clients have annual subscriptions in place, which actually reduce their annual spend even further. When you're dealing with an incident or using pipers to support your current integrity program, pipers can actually be ready to be deployed at a moment's notice. So by simply having your pipers on site, you can inspect your lines without long lead times, which optimizes decision-making and actions while reducing your costs. So simply drop a piper in your line whenever you want without any issues. So we do ship the pipers directly to the field, and they can deploy it when it's convenient for them. So if they have a scheduled run on Monday and for whatever reason the operator is not able to make it, they can deploy it Wednesday, Friday, the following week. That's the beauty of this, is there's no rescheduling service crews or equipment or tools. They just deploy it when need be. You let us know, and then we're ready to receive the data so we can do the analysis. So when we ship them to your field operator, we also provide an instruction video that explains how to activate our pipers, which is simply taking a magnet and touching a certain spot on the piper. It lights up, and that means it's activated and ready to go. And I'll explain a little more about the specifics of the pipers in just a minute. So when a run is completed, there's 2 ways to get the data back to INGU. You can ship the pipers back to us so we can upload the data and do the analysis, or we can provide a cable with the pipers, and then we would just show you how to basically plug it in like a USB, upload it, and FTP it to us so that we can begin the analysis right away without any delays. Another thing you might find interesting is that we do not charge for our pipers at all. So we don't sell them or rent them. Our business really does revolve around the data analytics. So each piper is used only once to ensure that we have the highest quality data with every run. Here's a quick snapshot of our pipers' safety and performance. So pipers are CSA certified and rated intrinsically safe and suitable for use in Class 1 Zone 0 environments. In 3-inch pipelines and larger, pipers can be run in pressures of up to 10,000 kPa or 1,400 PSI, and this has a runtime of 24 hours. In 2-inch pipelines, pipers can run in pressures up to 3,000 kPa or 435 PSI with a runtime of 2 hours. And pipers can run in temperatures from -20 degrees Celsius to 60 degrees Celsius or -4 degrees Fahrenheit to 140 degrees Fahrenheit. The data rate we're measuring with our magnetometer is 400 measurements per second, and our pressure sensor is at 100 measurements per second. So we can identify and localize welds and fittings along with hydrostatic pressure measurements and velocity profiles. And as mentioned earlier, we can assess the wall condition of your pipeline along with corrosion, deposits, and leaks. So our accessibility, or our accessible technology, has given us the opportunity to work with a complete range of clients around the globe, be it large or small, private or public, as well as we're working very closely with our agents such as PICA in North America, Hydrocarbon Support Concept in Nigeria, NW Water Services in Ireland, and Morgan Group in South America. And in addition to these companies that you see on their screen, which we're very grateful to give us permission to share their logos, we're also currently working with Shell, ExxonMobil, and Total. So as far as some customer applications, I've got a few slides to share with you that just give a bit of example of what the data looks like when we provide it in a report. So INGU can provide you with the ability to monitor multiple high-risk lines for leaks on a regular basis, simply by having pipers readily available on site. The benefit of running free-floating pipers in a liquid environment is there is literally no or virtually no background noise. So that makes it much easier to listen for leaks. The graph on the right is a spectrogram of audio recorded around the location of a leak signature in one of the lines that we screened. We perform deposit surveys with our free-floating deployment as well. And as I mentioned, with our leak detection, when running pipers in a liquid environment, there's little background noise, and also the piper is not hindered by friction. So if there is a deposit in the line, we can tell you where the deposit is, and that means you can do more efficient cleaning. A typical application would be to run the pipers pre and post cleaning, and then we can tell you the overall effectiveness of the cleaning, as well as the location of where the cleaning was effective and where it was not. So in this example, we ran our pipers attached to a cleaning pig in the same pipeline in 2018, 2019, and 2020. So I want to really reiterate how repeatable our data is. So as you can see from this example, the magnetic flux is virtually the same in all 3 runs. So unless there's been a change in your pipeline, we should see very similar data for every run. And this is how we're a bit different from a lot of the other tools out there. So our data is very repeatable. So when we do have a baseline run, we can overlay the data from subsequent runs over the baseline to see if there are any changes in the line. And so while performing regular monitoring, you have greater program control, early detection, which results in lower costs. So an example of this is how repeatable our data was for a project we did with Petrobras. This was in the past summer. This past summer, they wanted to test our technology to see if we can identify and localize an illegal hot tap. So what we did is we ran our pipers in the line to get a baseline. Then they created a hot tap, but did not tell us where it was. As you can see in the data example, the first run without the hot tap is blue, and after the hot tap is orange. Not only could we identify the hot tap in the green highlighted area, but we identified at the exact location. Having the ability to keep pipers on site and run them weekly or monthly allows you to be proactive instead of reactive when it comes to potential production loss from illegal hot taps. This is a run we did for a client last year where we identified corrosion in a section of the pipeline. In the graph on the right, the magnetic flux is shown in blue, and its typical spread is indicated by the green band. Locations with outlier magnetic flux are marked in orange, and the identified joint locations are indicated by vertical gray lines that you see in the background. In this case, we identified the outliers in our report, and our client did a verification dig based on our analysis. They ended up replacing this section of the line due to corrosion. This is an example of a verification dig that one of our clients did last year based on another one of our magnetic survey analysis. So besides identifying fittings and welds, we can also detect metallic features. So we can actually determine the difference between a good weld and a bad weld. And that's the example you see here. And in this plot, there are 2 crossings where the pipeline goes deeper and then comes up again, and then where it goes below a river crossing and then back up again. So it basically is just a quick snapshot of what a geometric survey looks like when we provide them in our final report. And including this map, we would also provide you with a list of the bends and the bend angles in your line. So if you don't have any history on your pipeline, if you've acquired a new asset and it didn't come with much information, this is a great way for you to not only get an assessment of the pipeline wall condition, but also where the line goes from start to finish. And finally, I wanted to give a big shout out to Chevron and thank them very much for their continued support over the past 3 years. So Chevron not only selected us as part of an initiative designed to advance innovative technology within the oil and gas industry in 2017, they put us to the test in a series of lab and field trials in 2018, and then directly invested in INGU in 2019 and accelerated our market development. So in 2020, Chevron's been deploying INGU technology across its business units. So if you haven't already seen the great video that Chevron made of our pipers, please visit our virtual booth. So I'm finally wrapping up my presentation today, and I want to thank you all again for taking the time. And please feel free to reach out to us if you have any questions or if there are any pipelines that you'd like to further investigate using our technology.
Great, thank you for that, Michelle. Well done for picking up where you left off. Did that
I've
really
got a bit of an echo in my ear here, so I'm just trying to figure out what's happening. Sorry about that.
Oh, that's okay. Sorry. Hope you can keep up with the questions here. There are so many questions that came in. People are obviously very interested in these pipers. And hopefully you'll get the questions afterwards to follow up with everyone individually. But let's start with Az, who asks, how do you map the data against the pipeline length? Did you get that one, Michelle?
Okay, I've got a bit of a delay here again, so I'll try to think, see if I can. Okay, sorry, I just got the question now. So we map the data against the pipeline length by a few different things. We've got various sensors that are in our pipers. So with these sensors, they're able to identify the welds in the line. So by doing that, we can locate where we are in proximity to the line. And we also, when we know the velocity of the flow, we can convert time to distance. And if we have an elevation map provided by the client as well, we can overlay that and be able to determine the distance of the anomaly in the line.
Perfect, thank you. So for everyone that's listening, the broadcast is about 30 seconds behind the live stream. So that was the reason for the delay on answering the question there. Hopefully Michelle can hear me now.
It's about a 30-second delay.
Right, well, I'm going to ask about the flow. How does the flow affect the data coverage?
Can you repeat that? Sorry, Danny.
Yes, the flow in the line. How does that affect the data coverage? And particularly looking at low flow lines like LNG lines.
So the flow, we ask when you do a free floating inspection that you keep the velocity at about 0.1 to 2 meters per second, so that and as a continuous flow as possible. So this way it provides us the ability to have a more consistent data coverage so that we can provide you with the best analysis possible. So the more consistent the flow, the better. And if you can keep it within the 0.1 to 2 meters per second, that would be our ideal threshold.
Perfect, thanks. How about pinholes? Leak detection thresholds. What's the minimum rate in like liters per hour that can be detected?
So we've actually, the leaks that we have been able to detect, it is a bit difficult to measure, but I believe the lowest leak we've been able to detect is 0.75 liters per minute. And that was with a very low pressure line. I think it was something like 5 PSI. So all we ask when we're doing a pressure or a leak detection survey is that we have some sort of pressure in the line, because the lower the pressure, the more difficult it would be for the leak to create a sound. So normally the leak would almost sound like a whistle. So in this case, the one where we did detect it at that rate, that was a very low pressure. So I believe we can go even smaller than that.
Great, thank you. One of the questions asked about how the pipers are retrieved at the end of the line.
Sorry, can you repeat again?
Yes, sorry. How are the pipers retrieved at the end of the line?
Okay, so when we run free floating, there's different ways that we're able to launch and receive our pipers. So for free floating, just to give you some examples of what we do, we use Argus valves, vertical pig barrels, conventional pig barrels, flange access, excuse me, and double valve chamber. And this is all for free floating. For receiving them, we've used things such as conventional pig barrel, witch's hat, Argus valve, and basket strainer. So wherever you can insert some sort of a mesh or strainer to stop a 2-inch ball from going through the pipeline, our operations group actually does work with your team prior to deploying the pipers to ensure that we have the best possible solution available for your specific pipeline, because every pipeline setup is unique. So we work with you to determine what would be the best solution in your case.
Perfect, thank you. Can you comment on the precision on the wall thickness readings and corrosion loss?
So when we're doing wall thickness, we don't actually measure the wall thickness in the line, but what we can do is tell you when there is wall loss of greater than 25%. So when we're running our pipers in the line, we can determine if there is different schedules. So a schedule 80 we can tell is different from a schedule 40. We can tell you when diameters have changed in your line, but not necessarily at this point in time tell you what your exact wall thickness is, just whether or not there has been significant wall loss. And this could be internal or external. So we can't at this point tell you if it is internal or external, only that in this specific area there has been some wall loss.
Perfect, thank you. Well, I think for sure it has a great application, especially as like a screening technology, and then you could go into more detail. And you'll get all these questions, Michelle, so hopefully you can respond to them all individually. I know there were some people asking for specification sheets as well.
Perfect.
So thank you for coming back on, and thank you for your presentation.